Stats, anybody? Any there? I think other than stats, all the departments have few of you. Just wait till one or two stats students join and then we can start. IT and MC I can see. Electronics and electrical also I think you are there, isn't it? Purnima is there from electrical. Smita is there from electronics. And statistics, anybody? Okay, okay. So Rangalong is there. So I think should I wait for 5 minutes or should I start? Only 11 of you are there now. That's 1/4 of the class. Sure. I'll wait for 5 minutes and then we'll start. And in the meantime, you want to have the first internal test after Puja or after Diwali? Means in your October last week or say November after Deepavali. Okay, Ananya is saying after Deepavali. Others is that okay? Okay, then we'll have it after Diwali because in case you are say November second week or so. Okay, Diwali, Kali Puja is in say November 4th or say in the November 8, 9 and so we can have a test. I'll keep the first one online and the next one we can have offline. Okay. Yeah, okay. Jitesh, we'll have it online, say 8, 9, 10 during that November. I hope that will be okay. We'll have it in the Google Forms and later on the second one I'll have it on offline. So in case you are to do some problems and other things that I'll keep it in the second test and the first one I'll keep it MCQ based. Okay. So I hope few of you have joined. So I'm sharing my slide. You can see my slides.
Yes.
Okay. So yesterday we had discussed the reasoning under uncertainty. So I'm continuing that. I hope I'll not be able to finish it off. A few probability distribution things will be left that we can have in the last week of October once the university resumes. So the common axioms of probability theory you already know. I'm just recapitulating that you have some formal mechanisms and rules and propositions, and out of them you have the following things that the probability lies between 0 to 1, and if it is 1 means it is true, if it is 0 it means false, and the union of A and B is actually A plus B minus A intersection B. So these axioms you have done in your school level. So I hope you know that. And probability of not A is equal to 1 minus probability of A. And I think this for the statistics students, this is your bread and butter. So similarly, you have probability of A is equal to probability of A intersection B plus probability of A intersection B bar. And sum of all the probabilities of different probabilities of A is equal to 1. And these you already have the idea. So I hope I don't need to explain these things, the common axioms of probability. Uh, I hope all of you know that, isn't it? You know that these things, I guess you remember of your school days. Okay, so this is very basic and school level probability theory. And uh, here these idea I think all of you have. I'll not ask the statistics students, but others, MCA, MTech IT, and MTech Electrical and MTech Electronics, I think all of you know this, isn't it? So I don't need to explain these axioms.
Yes, sir.
Okay, so coming to the joint probability distribution, also you have the idea. Only thing is that I will be doing some few things which I'll be say modulating with respect to our objective. Like given an application domain, if there is a set of random variables, we can encode all the relevant information in the form of probability. So that's why I was giving your example, means how long you are logging in and how long you're logging out, kind of thing. Or say for example, if somebody is electrical engineering, having electrical engineering degree, we know that he or she knows the basics of electrical engineering. And if somebody is having an electronics engineering degree, we know that he or she is having the basics of electronics engineering. But there is something in between, like electrical and electronics. Now a degree has come, electrical and electronics. So when somebody is there with electrical electronics, so it is something like what we have in case of say uh, half of now what happens is that if a electrical department is the or the people who are framing the syllabus are of electrical background, who are making a degree of electrical and electronics, you will see that there is more percentage of electrical engineering, and there is a less percentage of electronics engineering. And that is based on the probability. Why? Because the teachers of electrical background, they prefer to keep more electrical subjects. Similarly, if say for example, if I'm not wrong, you can see the IIT Guwahati website. They started the electronics engineering department first, and then they opened a electrical engineering department, and that they called it as electronics and electrical engineering. That is also triple E, and electrical electronics is also triple E. So the difference is that you'll see they'll have more electronic subjects than electrical engineering. Whereas IIT Kharagpur, which was an old IIT, at that time, long back, there was no electronics department. Normally, electrical department was there. So IIT Kharagpur electrical department was offering electronics engineering. So when they started the electronics engineering course initially, nowadays the syllabuses have modified, but when they started initially, they were putting more syllabus of electrical in that electronics. So that is actually means in general it is more comprehended wise that which thing you will be doing. Say for my department, we have the information technology course, and for computer application it's fine, we go based on the BTech computer science syllabus, and we go based on that. That is okay. But when we come to this IT course, what happens is that in our department it is all more balanced compared to other departments, is because if IT normal IT course, if it is conducted by a computer engineering department, they put more computer subjects, and if it is conducted by electronics people, then they put more electronic subject. So initially in my previous institute, we were the first to start MTech IT. So we put more electronic subject, or rather you can say more electives of electronics. Otherwise, we had to request computer science faculties to take a few OS or software engineering classes. But later on, when we started two master degrees in VLSI and communication, we handed over the IT and CS to CS department. So when CS department got the subject, they were having trouble in say taking the subjects. So what they did, they put more electives of CSE, and so that is kind of probability. This probability will be based on what is the probability that the teachers making the syllabus or conducting the course are from which background. So based on that, you can find out the probability of percentages of subjects in that. So that is one of the issues that happens time to time. Now that's why I was telling that in our department we don't have a problem, because I am from electronics background, Jayanta sir is from computer science background, Alak sir is IT. So we have a balance kind of thing, because we have 2% from. Had it been that Alak sir had been from CS background or say electronics background, one of us would one group would have been say more dominant on the other. So that always happens, whether it is your home decisions where say mother and daughter is in one side and father and son is another side. So if it is equal, fine. If there are two daughters, you'll see that this side is more stronger, or that side is more stronger. So these kind of things happen. And here there we have the inferences given in terms of points, and those points add up to make it, means out of 10 how many people are voting this side, how many people are voting that side. So based on that we have the probability coming into picture. So that's why I was telling that if I have done 10 classes, out of those 10 classes each class is of 1 hour. So if I consider offline, then there is one particular kind of thing, and if I consider online and in terms of the hours, then it is different kind of thing. That's why I was giving, say one person has attended 5 classes full, he or she will have 5 hours, and one person has attended 10 classes half, he or she will have again total summation equal to 5 hours. So there you have the probability distribution based on whether you are doing for the day wise login or you are doing instance duration of login. So here also we can do this kind of thing. So these kind of probabilistic operations may be different based on applications. If it is a application for electrical domain, it will be electrical domain. If it is for electronics, it will be electronics domain, and many more. But the main difference is that we have to have a numerical value, because when we calculate, the statistical students are more aware. When we calculate, we go based on the numbers, and we convert the numbers into this side or that side and take some decision. And when we are doing it for the computer also, we have to do it in that way. But what we want it to do is that even though it cannot think or feel like us, but based on the probabilistic theory, we'll take more, means like you can feel that there is more chances of rain here, or more chances because today it is cloudy, so there is more chances of rain. So if there is more chances of rain, say I'll not wear my good dress today. So these kind of probabilities you can do and you can infer. So we want the machines to infer, but for machines you have to put the numbers there. So for example, if we have probability of say capital V1 equal to V1, V2 is V2, like this, you have n number of variables, and here we assign different probabilities and possible combination to these values of these random values. So for example, let us consider a domain, say 3 Boolean random variables. One is a bird, a flyer, and young. So how do I correlate that? Anybody any idea? Bird, flyer, young. Anybody any idea how I'll correlate this? Here I am bringing into account all the birds and all the birds that fly and all the young ones that fly, or I'm relating 3 things: all organisms that fly, all birds that fly, and all young creatures that fly. Getting? You have got the problem which I want to bring into picture?
Yes, sir.
So when we enumerate this table, let us just take a random hypothetical table. Say this is a particular table. So here you see bird, true, flyer, true, young, true, probability 0 means what? A young bird cannot fly. That all of you know. It has to be taught to fly. The mother bird tries to teach the bird to fly, isn't it? That is bird true. T stands for true here. That I think I don't need to tell you. And F stands for false. So bird true, flyer true, and young true. Now, if a bird is there and it is a flyer, means it flies, and it is young. So if it is young, it may, even if it flies, but there is no chance of it flying. So the probability is 0. Getting what I want to mean? Bird, flyer, young. When all three will be true, then the probability will be 0, because the young ones of flying birds also don't fly. Clear? The first one, first line.
Yes, sir. Yes, sir.
Now, if I take the last one, not bird, not a flyer, and not young, what will be the probability? That will be more than half the population, so it is 0.5. Means you are also, say for example, you are not a bird, so it is false. You cannot fly, that is also false. And you are not very young. So maybe younger than me, but what I'm saying is that young means kids. You are not kids. So as you are not small kids, so that is also false. So half of the population of organisms are in that way. So that's why it is 0.5. You can see. Now take the second last one. Bird false, means all those who are not birds and not flyer, but they may be young. So say 25% of the population may be young population, which are neither birds nor flyers. So it is having probability of 0.23. So you can see 75% is already segregated here. Okay, 0.23 and 0.5. Clear? Here?
Yes, sir.
Yes, sir. Now you see rest of the part. Rest of the parts you see. Now if I take the bird population to be around say 0.27 part of it, or say 0.25 part of it, you see here 0.2 are bird, true, and flyer. Most of the birds fly. There are few birds which don't fly, but most of the birds fly. So bird true, flyer true. Now if it is not young, it can fly, isn't it? So it is 0.2 here. The second one. Clear?
Yes, sir.
Yes, sir.
So next, after you have completed 0.2 here, 0.23 here, and 0.5 here, how much is left? So 0.43 and 0.5. So 0.43 and 0.5 is 0.93. So only 0.7 is left. 0.07 is left. Now out of this 0.07 or 7% of the population, you are having birds. So out of those birds, there are some flightless birds. So those flightless birds are in this group. So flightless birds are true. Bird is true here. False, they are not flyers, so they are flightless. You can see the third and fourth. True and false. True means they are birds. False means they are not flyers. Now when they are not flyers, even when they are young, true, then also they are not flying. And when they are not young, then also they are not flying. Only difference is that when they are young, the probability is 0.04 of not flying. And when they are old also, there is probability of 0.01 for them not flying. So most of the birds are concentrated here. Rest part is not a bird. The other two groups of not a bird, but they can fly. Now there are chances of non-birds flying very less. Okay, so flyer true and young true. So that is very less probability that some animals may be there which are not birds, but they can fly even when they are young or when they are not young. So that is 0.01 and 0.01. Okay. So this is just hypothetical probability. Now you keep this probability distribution in mind, and whatever problems or say examples I'll be giving based on this probability chart. Okay, main thing is I have just taken a hypothetical probability. You can take any kind of probability here. I have just taken a hypothetical one and I'll be giving the analysis based on that. So here we have 8 rows, and as there are 8 rows, there are 2 to the power 3 different ways because we have 3 variables. I think you are aware of this, because as that is, and if you go by the Boolean, it is something like, if you are having 3 items, what do? We do 0 0 0 0 0 1 0 1 0 kind of thing we go. So you can consider this is 0 0 0, then 0 0 1, 0 1 0, 0 1 1, then 1 0 0, isn't it? You can see from top down, you can put false equal to 0 and true equal to 1, and you get the all 8 bits. Okay, so you have 8 rows for the 3 variables, and it can be anything like n Boolean variables, and you can have 2 to the power n. Here it is 3, so it is 2 to the power 3. And if there are n variables and there are k possibilities, so this will become k to the power n. So these things because we are having 3 different variables here, and sum of all the probabilities obviously will be equal to 1. And for any kind of Boolean random variables, the table will be having 2 to the power n minus 1. So 2 to the power n minus 1 values that must be determined completely to fill in the table. Why you need 2 to the power n minus 1? Because the last one you can get anyway by subtracting the, if you get 7 probabilities, if I don't give you the last one, then also you can calculate the last one from say 1 minus the sum of all others, isn't it? So like this you can get. So if I consider this one, so for this particular table, I have already discussed this table. Say if all the probabilities are known for a, say, any full joint probability distribution table, so we can have different probability statement for them. Say for example, if we want to say p bird true, that is pb. P bird true means what is the probability of birds. Now when I say the probability of birds, means probability that the organism that I'm considering is bird, means combination of all these 4, because in these 4 bird is true, irrespective of whether flyer is true or false, young one is true or false, because young one true and false and flyer true and false are giving me 4 possibilities, because it is 2 to the power 2. 2 to the power 2 is 4 possibilities, but only thing that I'm keeping constant is bird equal to true, means I'm taking all the bird species. Okay, up to this? The first 4 are for the bird species, and last 4 are for non-bird species, those animals who do not belong to the group of birds. Clear?
Yes, sir.
Now, so what is the total number of birds? You just add up these, means where bird is true. The first one is 0.0, the next one is 0.2, next one is 0.04, and then it is 0.01. If you add them up, this is equal to 0.25. So 1/4 of the population that we have considered is bird, whether it is flightless or which can fly, that is secondary, but we have considered a population where 25% of them are birds. Clear? Other are not birds. Clear? So either they are birds or not birds. So 0.25 of them are birds, and obviously that means 0.75 of them are not birds. Then we come to the next part where I'm saying that bird is true and flyer means flying birds. Okay. Bird is true. Flightless birds. Flyer is false. So these are flightless birds. Okay. Flightless birds like, I hope you know, रोज जो खाते हो मुर्गी, or ostrich or ducks. These are all flightless birds. Some of the ducks are flying, no doubt, but most of them, some varieties are flying and some varieties are not flying. Uh, uh, Chickens, they don't fly; they don't fall into the flying group. Is it disconnected?
No, sir.
Can you hear me now? You can hear me?
Yes, sir.
Okay, so I hope it has switched back to the mobile network automatically. Fine. So you have bird and flyer false. Flyer false means we are taking flightless birds. So what will be this flightless birds? How many of them? Can you tell me? Anyone? Flightless birds. P probability of B and F bar. B and F bar means you take for means the first four out of those first four you take where F is bar. So you take the second, third, and the fourth, isn't it? Statistics, guys. Third and the fourth, isn't it?
Yes.
So what will be that? How much?
It will be, sir,
How many?
0.02.
0 point?
02.
How 02?
Wait, sir. Sir, 05.
Yes, 05. Yeah, correct. Okay. I hope all of you got that. This is a simple thing. Means what we are doing. I have put your this bird true and flyer false. Now bird true and flyer false may be with young true and young false both. Okay, so we have taken both the cases and it is 0.5. So there may be some conditional probabilities also. So conditional probabilities are very key for reasoning because based on some conditional properties I'll do. Just like kids will say, you if you give me a lollipop I'll do this mathematics, otherwise I'll not be doing the mathematics. So there may be some conditional probabilities also, and there may be that he is not listening to you, maybe you can give. So we start bribing the kids when they are small itself. So if you keep quiet or if you don't disturb me I'll give you a chocolate, this kind of thing. So conditional probabilities are key for reasoning because they formalize the whole process and also provide accumulating evidence and updating the different probabilities based on new set of data. So if we know there is a 4% chance of person having cavity, then we can represent these prior information via unconditional probability like P cavity is 0.04 means probability of a person having cavity is 0.04. Now, if we know about the food habits of that person, that we know this person is always having chocolates and sticky things, sweets, and he is not brushing his teeth. So the probability of cavity will go high up. And if this person is regularly taking care of his or her teeth, the probability of cavity will go down. Okay, so somebody may be having regular say brushing and other healthy dental system, and somebody may be having unhealthy dental system. Add to that unhealthy food habits, it will increase the probability of cavity. Okay, so a person if he is having some symptoms of toothache, now there we can take the conditional probability of both of them together, cavity and toothache. So chances, there will be a probability of having cavity if there is toothache, and there is a general probability of toothache. So we can compute them together. So if PAB equal to 1, then what we can do is you can say have a propositional logic, say B greater than, is equal to A. So similarly, if PAB equal to 0.9, then there is a 90% certainty. Okay, so these are different conditional probabilities. Other than statistics students, the MTech and MCA students, have you gone through this conditional probability? I think in school you have gone through. In BTech, have you gone through? or MCA students during their BCA or BSc, whatever. You have gone through that. So these are very common things. Others, MTech guys.
Yes, sir.
Okay.
Yes,
So
statistic we have studied in mathematics.
okay. So in other words, you have implication of fuzzy, and these particular probabilities make the things fuzzy, and if it is not absolutely certain. And I hope my MTech students have taken up the fuzzy logic, and it will be more beneficial for them because they can apply this kind of logic along with these probabilities in, say, AI, machine learning, data science, this kind of thing. And electrical guys also, if you have taken a course like fuzzy logic, it's very important for you for fuzzy control and other things. For electronics students also, you can do that. And statistics, they have already studied fuzzy. So if you see here, you have a evidence like E1, E2, E3 up to EK. There are different evidences coming time to time, and based on that, you formulate the queries PQ, E1, E2 up to EK, and you can find out the degree of belief. The degree of belief is corresponding to the degree of probability kind of thing, and you can have from this set of events either these or different evidences for these events, and either you have based on the belief network. Later on, maybe after Puja, I'll be discussing the belief networks. If anybody who is say so you can have different kind of things time to time. Rangalong, you are having some network issues. Others, you are having this network issue, or you can hear me?
No, sir. We
Okay.
can hear you, sir.
Okay. Okay. Maybe Deepjyoti will be later on helping out. Anyway, so you conditional probabilities are there. So these conditional probabilities, this is there in general conditional probability formula, which I think all of you are aware of. That PAB means when I'm taking PA conditional B, then it is PA conditional B intersection divided by PB, or PA and B divided by PB, because this intersection is PAB. Okay, so it is the conditional probability general formula. Statistics students, I think, if you remember these things, you have already done these. So one way of looking into this is using PB and joint probability PAB. So you have a joint probability PAB and a conditional probability PA for B. Okay, so two things. One is PA B, which is, this is the conditional probability. I think you can see my cursor there. And PA comma B is the joint probability. So one is the conditional probability and one is the joint probability. I hope you don't confuse between the two things. When I'm putting a bar in between A and B, that is a conditional probability. Okay. And PA comma B is a what? Joint probability. Okay. Clear? So going back to the old problem. So if we go for this, say we want to compute P, not a bird but flying. So you want to find out which animals who are not birds but they can fly. So you can find out a joint probability for that. So if it is not a bird but flies, is equal to not a bird flying divided by all the flyers. So that is the conditional probability. If I find out this, what is this? P not a bird but flying is actually not a bird flying young and not a bird flying not young. So, and divided by probability of flying. So if you see this, it is 0.01, 0.01. So it is this. Okay. So if you are able to calculate how many and that is organisms fly, TF means those who fly, then how do you calculate this flying? Flying means you take all the true flyers. So true flyers are this 0.2 here, and here it is 0.02. So it is 0.22. So it is 0.02 divided by 0.22. So 0.02 divided by 0.22 is actually the conditional probability of P, not a bird but flying. Okay, clear up to this?
Yes, sir.
Okay, so same thing you can do for, you can do some normalization also, where you for computing you can do say P not a bird, sorry, bird and flyer. So you can do in this way, bird and flyer. The earlier one was not a bird and flyer. Here it is bird and flyer. Okay, here B bar is not there. Bird and flyer, if you see. So here is the same thing. Only difference is that instead of not a bird, we are taking bird. So it is 0.2 and probability of flyers. So now you know that if you take these two together, this plus this, not a bird flyer and bird and flyer is 1. So in total it is, you get 0.22. Okay, clear up to this? Clear this part? So you have two conditional probabilities. One is not a bird and flyer, and the other one is probability of bird and flyer. So probability of bird and flyer and probability of not a bird and flyer together is 1. So if one is your 0.091, the other one is automatically 0.89 kind of thing. Sorry, 0.81. Okay. So I hope this conditional probability is okay with you. So there are some important rules regarding this thing. The product rule, PA comma B is equal to PA conditional B multiplied by PB. There is chain rule. Chain rule you are aware of because you have done it differently, maybe for digital logic. Here in the, it is the similar thing, only first is PA conditional BCD multiplied by PB conditional CD, and then PC conditional D and PD. So like this you can have chain rule. And conditionalized version of the chain rule, you are having this normal chain rule, and if there is a conditional version, you will apply this conditional version here. Then there's a Bayes rule. I'll spend a good amount of time on the Bayes rule. I'll be today completing just before the Bayes rule. Because Bayes I'll be taking later on. Otherwise, because Bayes classifier is very important for neural network. So anybody prior to this course have any idea of neural network?
No, sir.
Okay. Any one of you who has any idea? Okay, so we have a Bayes classifier which is very important, and Bayes rule is there. I'll be discussing them in details after the puja break. Prior to that, I'm just giving you the basics here. This here you see PAB is again conditional probability, where it is given in this format, and we go on updating. So updating thing is very important here. That is why we use the Bayes classifier in our neural network. Is something like our neural networks, actually our brain networks, what happens is that today whatever is the condition, tomorrow may not be the same condition. So you have to keep on updating yourself. So when I say was a UG student, I studied in only neural networks. Later on, what happened? This neural network and normally computer science guys, they studied artificial intelligence. So they used to study knowledge representation, how they will do it in machines and other things in during our UG days, and neural network. Now what has happened? The AI, deep learning learning, machine learning, all have combined to one group. Earlier, neural networks was a separate subject, and artificial intelligence was dealing with the knowledge representation and other things. Now it has merged to some extent. Why? Because nowadays most of the things we are doing using deep learning and machine learning, which are now becoming a part of AI. Earlier, they were used as separate entities. Neural network was a separate version of research carrying. So now many things have merged together. Earlier, students used to study a microprocessor 8085 only. Nowadays, nobody studies 8085 because 8085 architecture is totally different from what you are using today. And later on, we had a advanced course on 8086. Then 8086 had gone ahead with 286, 386, 486, the 586, which is called the Pentium. Then you have Pentium 2, 3. Then Intel, they started say bullying us, like putting Pentium 4, where they put the math core processor and normal thing together. Then they started the TikTok model, which I referred to in one of the classes, if you remember. TikTok model is, at a time they'll change the design, and the next time they'll change the VLSI technology. Then again technology. So what is happening is that they are spending money on research and they want to get it from you. Say Tasadik wants to buy a PC today. Now today, when he'll go to the market, if he is not very much aware of the processors, what will happen? They'll say, "Aap 10th generation lenge ya 11th generation?" Bolega, what do you mean by 10th generation or 11th generation? Somebody will say, "No, I have a 12th generation." He'll say, "Okay, if I have money, I'll go for 12th generation. If I don't have money, I'll go for 10th generation." So like that you can go, or you can see that, see, I can get say 16 GB RAM with the 10th generation, whereas the 12th generation I can get 4 GB RAM for the same price, same 50K if I'm spending, I can get this. So then he has to, if he is not aware of what is the system, they'll try to sell whatever they want to sell him. Okay, so he has to be content aware. He has to know the probabilities. What is his role of work? If you are doing only documentation work, you are not doing high-end programming or high-end gaming, you don't need a graphics processor. A i3 is enough for you. i5 is, say, okay for those students, say, who will be doing some amount of processing, and to some extent you don't need a very high clock speed or so. Somebody who is working, who is not working, so either working on deep learning with TensorFlow and other things, he may require a i7 processor with graphics card, or a person who is into gaming, who is playing a hardcore game. I'm not saying that small means with full graphics games, they will require a i7 processor, and that also it has to be having a relevant RAM and a relevant graphics card. So here the technical details and the you have to keep many things in mind. One is set is the technical details. Second set is whether you have gone to a shop which is having the latest models, because say if you don't have the money, you go to a shop which can give you credit and other things, then it's a different thing. And you just want to buy a PC to do your, say, project work, that is a different thing. Like a statistics student who will not be using a R or SPSS. Statistics students, have you used R or SPSS, any one of you?
हाँ सर, आर किया था।
R किया था, तो R में तुम लोग माने ओनली R किया था या R विथ पाइथन किया था?
सर रोहित पाइथन किया था कॉलेज में, लेकिन यूनिवर्सिटी में सिर्फ आर किया था।
Okay, so R and Python both are open source, so they can use that. But say, for example, they are not into programming. The statistical analysis can be done with SPSS also. It is a costly software. But what is the advantage? You don't need to do programming yourself. You have to say, I want the data in this format, and they'll give the data in this format. I want to say, like somebody is of social science or who doesn't know about programming, he is giving some questionnaire formats and they are modulating it and giving it to them. Like some of the PhD scholars of humanities and arts department who are doing the common coursework, they are learning SPSS from me for their PhD coursework. So they are doing SPSS because they are not having a mathematics background, or they are not having a programming background. Say they want a data in this format. They'll say, I want the data in this format, they'll be giving it. So here the neural network where you can apply Bayes is needs to update itself. Say for example, Payal said that she knows R. Now if she didn't know R, or she didn't update herself, then what will happen? She has to use SPSS. So here the addition of the or updating of her with respect to the R is making it this. Like some of my MCA students who are doing this time project under me, not this batch, but the other batch, one girl and one boy, both are doing project under me. So I asked the girl and the boy, said, do you want to work on this project using MATLAB or Python? The girl said, I'll work on MATLAB. The boy said, I'll work on Python. Now the boy said he will work on Python because he wants to he will reject, as well as he wants to be placed in a company because Python is in demand for the say software companies. The girl is saying MATLAB because she is not very good in programming, and she will work out, she wants to work out on the project, and she wants less of coding or something. So that is based on whether the boy wants to update himself, where the girl doesn't want to say it's okay, I want the master degree only, and maybe later on I'll do something else. So there is a difference in the priorities, and there is a difference because that's why I said the reasoning under uncertainty. So I'm reasoning here. Why might have she chosen MATLAB and why might have he chosen Python? So I'll be reasoning under the uncertainty based on the different conditional probabilities that are coming for Python, conditional properties that are coming for MATLAB. Okay. So here the Bayes rule, whatever is written, is having a emphasis on updating. That is why it is used in the neural networks, because our brain networks constantly update themselves. So if I give say money to somebody, as a say he wants some $100, I have say okay, I said okay, you take this $100, maybe you can return it to me say after a week or after a month. Now if he doesn't return it to me, I'll understand that he is not a say good person with for the money matters. So next time when he asks, even if I have the money, I'll not say give it to him. So that means I have updated myself about the logic of that particular person. The same thing if I do for another person and he returns me the money in time, then the next time also if he asks for it, I'll be giving it to him, because I have updated that okay, this person is a genuine person, because I'll update. So this time, last time he took 100 rupees from me, he has returned. So I hope this time he's asking for 500 rupees, I can give it to him because he will return it. But the other person who has not returned the 100 rupees, I'll say, अरे last time का 100 rupees ही तुम नहीं दिया, तो अभी तुम 500 क्या मैं तुमको 50 rupees भी नहीं दूंगा. So that is the way in which we update ourselves in our social scenario or naturally. So the same thing has to be done for the neural networks when new information comes, and there here the probabilities will change, and based on the change of probabilities we'll update the next set of probabilities or the conditional probability. If probability A is updated, automatically probability B and probability of A conditional B and A joint probability B will update themselves. Getting? I hope you are getting this. So
Yes,
Bayes
sir.
rule is for updating and emphasizing. That's why we use Bayes rule for our neural networks or artificial intelligence, so that we are able to update it. So the terms PA, PB are called the prior or marginal probabilities. We start off with it. We start off with it because when you want to handle a neural network, initially you have to give some random probabilities. For my students whom I taught DSP, MCA and MTech IT, I think I had discussed it. There is a square root algorithm. Electrical, electronics or statistics guys, do you know the square root algorithm? Square root algorithm. MCA students, I think you remember, I discussed the square root algorithm in DSP, MTech IT also.
Sir, we might have studied, but we have no idea about it now. Maybe we'll
Okay.
get to know if you give some hints.
Okay, the hint is that for a square root algorithm, there is a particular formula in which the basic formula is that you have to initially take a guess value. Okay, say for Tasdik, you take a guess value of root 2 to be 0.5. Okay, and say Deepjyoti takes it to be 1, and say somebody else, कौन है यहाँ पे? Say Ananya takes it as say 1.5. So when you start the guess value, after that the algorithm is systematic. There is a formula, you have to apply the formula iteratively till present value and the next value are not equal to each other. Present
Yeah,
value
yeah, sir. We have studied it. Yes, sir.
yes. So the person who is taking zero point 0.5, he is far off from the, because you know that the square root is 1.4142. So square root of 2 is 1.4142. So if you take 0.5 as the starting value, and if you take 1 in the starting value, or you take 1.5 in the starting value, the number of iterations will be different. But all of you will, based on the algorithm, will reach the final solution of 1.41 or 1.4142, means whatever is the number of decimal place you want to go down to. You can reach the solution. You can reach the solution, no problem. But the person who is doing the initial guess more near to the original value, he will reach faster, isn't it? The same thing happens when you go to somewhere. Say first time you are coming to the university. So when you are first time coming to the university, if you go by the GPS, university will be pointed somewhere, and if you go by the person who knows it, it will be pointed somewhere. But if there is no geolocation of the IT department, you'll not be able to find it directly. You have to ask 2 or 3 persons. Now, if you can guess it like, say you have heard that electrical and computer and IT departments are on the same building. So if there is a geolocation of electrical or computer science, with that you can come to IT department also. Or you know somebody who will say, अरे ब्रिज के बाद वाला जो फर्स्ट बिल्डिंग है वही है. So अभी वो फर्स्ट बिल्डिंग करके वो किसी का क्वार्टर में तो नहीं घुस जाएगा. They will expect, अरे वहां पे कपड़ा लटक रहा है, that cannot be a department. Okay, so the based on the information you will update yourself. That is the basic idea. Okay, so base rule is mainly for updating, and based on our but whenever we update, previously prior to that we have to take some marginal probabilities or some guess values. Now if the guess values are near to the original, the time required will be less. If the guess values are far from the original, time required will be more. That is as simple as that. So PAB is called the posterior probability because it is derived from the values of A and B, and whatever is the value of B, because you divide it with B, isn't it? So as you divide it with B, it is called the posterior, means later on probability. And initially you start with PA and PB, which are the prior or the marginal probabilities. So two things, one is the prior probabilities and one is posterior probability. So posterior probability will be after you change, means due to this being equal or not equal, you are changing some probabilities PA and PB. Along with that, you change the posterior probability. So you can have a conditional version of the base rule also sometimes, because on application, and you can have a conditioning rule. So summation of the whole thing you can have. So probability of not B conditional A is equal to 1 minus probability of B conditional A. So B conditional A and not B conditional A are obviously correlated, because some of this not B conditional A and B conditional A will be again equal to 1. Okay, clear up to this?
Yes,
So
sir.
combining thing for this joint probability distribution, I'll take up later. There are some evidence for diagnosis and other things. So this I'll take later because I have to correlate it with the base classifier. I hope till this part you have understood this things. You just have a look. Most of the things are what you have already done in school level, or at least in your UG level if you have done some statistics or probability distribution course. Some of the things I have taken from Sheldon Ross. Sheldon Ross book on probability. Statistics students, have you gone through that book? So Sheldon Ross, have you gone through the anybody has gone through the so Sheldon Ross book? Anybody? Do you know there is a probability book by Sheldon Ross?
Yes, sir.
Yeah, you are a statistics student. Others, I'm asking. Others?
No, sir, we have not gone through the book yet.
See, anybody who is preparing for GATE, that probability part, you can have a look for Sheldon Ross. I think it is available in K-Nimbus account. You can have a look. I'm not sure about that. If anybody, because that is a very important book for the probability, and anybody who is working on your say master degree project which involves probability or say statistical analysis, you can have a look in that book. I forgot the name of the book. You can just Google statistics and probability by Sheldon Ross. I don't remember the book exactly. The name of the book exactly. Normally we refer it based on the author names. So Sheldon Ross is a very good book. So if you and it is not that it is a very hard book to understand. So I have taken up some of the things from there. But these are available in any book. You can. It is not that you have to go to that book only. You can go to any book. The rules are the same. So whatever I have taken up is to some extent from that particular book. You can take any random probability book. My just problem is that my problem is not with the Indian authors but the Indian publishing. What happens in the foreign publishers is that even if it is Indian author, people who publish the book or print the book are qualified people. And in India, what happens, many publishers are there where say the people who finally see the final version of the book, who do the proofreading, are not very qualified. It is not the problem with the authors. The problem is with the publishing house. So publishing house in India, for the cheap labor, don't have qualified people in the publishing houses. So that is the main problem. Okay. So you can have a look in any books, but the chances of Indian printing, if it is reputed printers, it's not a problem. If it is less reputed printers, जैसे हमारा क्या न्यू एज हो गया और जो हमारा कुछ कुछ हो गया जिसमें मतलब इंडिया में प्रिंटिंग होता है, if they don't have good proofreaders, there are chances of being errors in the book. Even though writer has written correctly, while printing they make some mistakes. So that is the main problem with Indian publishing houses. Okay. So I hope up to this part is clear. I'll be taking up after the puja break. So have a nice puja. If you have some questions, I'm there.